All right, good afternoon, grade eights. I hope that you guys are all doing well and that your week is treating you guys well so far, too. Grade eights, I know that many of you are currently in the midst of your June exams. So I hope that that is going well for all of you and that you guys are finding success in the papers that you are writing or have written so far. Guys, it doesn't change that we still have our lessons each week. So we're back again for another lesson this week. I hope that you guys are ready for it. So I just want to give everybody an opportunity to quickly join us on the different platforms and hop onto the live stream, and then we will get going with today's lesson. All right. In the meanwhile, I'm just going to start by sharing my screen with you guys. I do apologize for the glare in the background. Unfortunately, I can't do too much to avoid it for right now. But as soon as I stream my screen, it shouldn't be too much of a problem. All right. So, grade eights. Just very quickly, guys, we do have certain work planned for today's session, but given that it is our exam period at the moment for many of you, I will give you guys an opportunity to just ask questions if there's something specific that you want us to go through now in preparation for your exams. Maybe you've already done paper one and you just want to do a little bit more prep for paper two. If that is the case, please just type a message into the comment box asking to go through a specific topic, and then I'll take a look at it and see if it's something that we can cover in today's lesson. I'll give you guys 2 minutes to quickly do that, but in the meanwhile, you should be able to see all of the scribbling on my screen. Um, but like I said, we're going to wait 1 or 2 minutes for everybody to just quickly join us and then get going with today's work. All right. So if there is a specific topic you'd like for us to go through, please type the name of that specific section into the comment box now so that I can consider maybe going through that to help you guys for prep for your exams that you have left. All right. I'll chat to you in about 2 minutes' time, grade eight. All right, grade eight. It's time for us to get going, guys. I haven't seen any specific recommendations so far with regards to what you guys would like for us to go through in this lesson. So, what we're going to do is quickly chat about the world of measurement. This is something that's really important for you guys. You move to grade eight. It's tested quite directly at this stage. So let's go ahead and talk about area and perimeter, but we're going to focus on area. Guys, more specifically, we're going to take a look at the area of circles, but also compound shapes. All right. So today's date is the 18th of June, if you want to write that down. Today we are talking about the wider topic of measurements, but specifically area and perimeter of 2D shapes. Okay. Please remember that area and perimeter is only applicable to 2D shapes. So there's uh, no point in writing in 2D shapes in your heading. But let's get going with today's work, guys. We've waited long enough, so let's get started with our definitions. First things first, you need to make sure that you thoroughly understand the topics of area. Yes, although you would have covered it relatively extensively in grade 6 and grade 7, it's still important for us to uh, make sure that we understand it in sufficient depth for the new grade 8 level. All right. Now, somebody has mentioned just now that they would like to go through exponents, guys. Exponents is a topic that we have already discussed. So, unfortunately, it's not a topic that I can go through again. But like I say, every lesson, grade eights, all of the sessions that we have are recorded. So you can always go back and watch the lessons that we had on those topics to sort of brush up on your understanding of exponents and how all of the work in that section is tested and also applied in exam settings. Okay. So what I will do is at the end of this lesson, I will give you the dates that you can actually, I can give it to you now. You can look at Monday, the 10th of February. On this day, we had a lesson on the exponential laws, which is a very big section of work. And then again on the 17th of Feb, we also had another lesson on this topic. So if you go onto the Facebook page or here onto the YouTube channel and you look for these dates specifically under the grade 8 sections, you will find what you are looking for with regards to that topic. Okay, I hope that that does help you. I would suggest you go ahead and take a look at those lessons to make sure that you understand it. If you want grade 8, if you still feel a little bit shaky on your basics of exponents, you can also go and take a look at a recording that we had on Wednesday, the 19th of March. And this was all of the fundamentals of exponents, but keep in mind that this was a grade 7 level. So this should be more revision. But if it's something that it's one of those topics that you found to be a little bit evasive in the sense that it's been a bit difficult for you to get a grip with, then I would strongly recommend you go and watch these two recordings. These are all of the basics that you need to understand about exponents, especially at grade 8 level, grade 7 level, and it discusses everything from bases to powers and negative bases as well. Okay, so go and take a look at these four recordings. There's a lot of work in these four sessions. I hope that it's work that will help you guys. But like I said, go ahead and take a look at those recordings first. And if that still hasn't really helped you, then you're more than welcome to come and ask me about more specifics in our next lesson. Okay, but this really should cover pretty much everything you need to know. So go ahead and take a look at those recordings, write the dates down, and you should be able to find them quite easily. Now, with regards to measurement, area and perimeter, grade 8, that's going to remain the topic of today's lesson. So let's get a little bit more invested into this work. First things first, the perimeter of a shape is the length of the outline. It is the length of the outline of a 2D shape. All right. length of the outline of a 2D shape. No, perimeter does not apply to 3D shapes. Remember that perimeter has a symbol of capital P, and more importantly, is measured in standard units. So when we write an answer down for perimeter, we do not use centimeters cubed or meters squared. We stick to the standard measurement units. Okay, what does that mean? We are only working in plain old centimeters, millimeters, or kilometers. All right. You must make sure that you understand that. Then, what do we need to know about the topic of area grade uh, grade eights? Well, remember, we're talking about 2D shapes, so we need to be able to calculate the perimeter and the area, not just for your simple squares, rectangles, and triangles, but also for our circles, which is something that catches a lot of students out. So while this lesson is going to be a little bit more basic, when students don't understand area and perimeter grade eights, it's usually because there's some kind of fundamental misunderstanding in the basics. So that's why we're going to go through the basics today. And then in our lesson next week, we will go through surface area and volume, which strictly apply to 3D shapes. So area is the amount of space taken up by a 2D shape. Okay, now, yes, it does have a symbol of capital A as well, but there are some formulas that you now need to know when it comes to area, and we're going to chat about those in a second. Please remember, guys, that area is measured in squared units. Okay, so when we give our answers, you should be comfortable by now with saying that our answers must be measured in millimeters squared, centimeters squared, and so on and so forth, right? So please make sure you write down these differences. Guys, this is not going to be a lesson going into extreme depth into area and perimeter. This is something that you guys definitely should have an understanding of, but it's more so going to be the equivalent of a cheat sheet. We're going to go through everything that's really, really important. Okay, so let's take a look at perimeter first. We know that perimeter is the length of the outline of a shape, and so we add up all of the lines that create the outline of a shape, right, in order to get our answer. So let's go through some examples right under here. Under all of this work, you guys have got a few seconds to quickly copy. Right. Now, the first example that I'm going to show you guys is just for the sake of reminding you of the layout that is going to be useful for you to apply when you're going through these kinds of questions. Right? So, um, the question for these examples is going to be calculate the perimeter of the following. We're going to just go through three examples and then we're going to move on. So let's start with a very basic shape. We're going to start with a rectangle. Right, so for this example, grade 8s, we're given the following shape over here. And you could be told, for example, that the length of this side is 4 centimeters, and one little piece over here is 3 centimeters, and they are equal in size. So we know that each of these would be 3 centimeters in that case, right? 3, 3, and 3. Now, when we go ahead and calculate the perimeter of a shape, we always start our question by stating that the perimeter has the symbol P. Why do we do that? It's so that we don't have to keep writing the word perimeter over and over and over again. So the perimeter is the length of the outline. Now, I recommend that you guys select a corner on your shape and make a little mark like this. I picked the top left corner of my shapes, but you can start anywhere, just so that as you move your way around the shape, you know where you started when you make it back to that starting point. So we're going to have 3 plus 3 plus 3, right? The three threes at the top, plus 4 along the bottom, plus the next three threes at the bottom, and the 4 centimeters on the left-hand side. If you guys want, you are, of course, more than welcome to go and fill in the missing information so that you have all of the numbers right on your diagram. Just make sure you do that in pencil so that if you make a mistake, you can erase it. Now, these red lines in the center, grade 8, we do not include in perimeter because they are not part of the outline, right? They just form part of the shape. So we're going to start at the top left over here, and we have 3 centimeters plus 3 plus 3. That covers the top side of the shape, plus 4 centimeters moving down the right-hand side. We can then add another 3 threes for the little 3 subdivisions across the bottom, and finally a last 4 to go up the left-hand side over here. Right, so when we add everything together, we get a total of 26. But we can see from our diagram that we are working in centimeters, so please make sure that you include centimeters on the end of your answer. You need to remember that without putting the correct units on the end of your answer, you are not going to get all of the marks. Okay, there we go, guys. Nice and simple. That is what you need to make sure you are capable of doing when it comes to calculating perimeter. That is absolutely the bare minimum. Right, so perimeter is not really that tricky, right? That's example number 1. Now, you can use formulas, grade 8. Please listen to me closely when I say this. You have a choice when it comes to the topic of measurement, right? So when we're discussing perimeter, area, surface area, and volume, it is your choice whether or not you decide to memorize all of the formulas or only some of them. In this example over here, it was quite easy for us to just go and add up all of the individual numbers. But we already know that the perimeter of a rectangle in the world of measurement is equal to 2 times the length plus 2 times the width of that rectangle. Now, what we've done on the left over here is absolutely correct, but there is nothing stopping you from going and using the formula. Right? In this case, if we wanted to use the formula, The length of my rectangle is 3 plus 3 plus 3, which gives me 9. So I would have 2 times 9 plus 2 times the width. The width of my rectangle is 4. So I can substitute that in. 2 times 9 is 18, plus 2 times 4, which is 8, is going to give me 26. So again, we land up with an answer of 26 centimeters, right? It doesn't matter which way you decided to go about finding your answer. If you've done everything correctly, you will still get the same result. So it's up to you whether or not you want to memorize the formula for these kinds of shapes. Okay, but some of them are pretty self explanatory. In other words, it can be quite easy for us to find the perimeter without having to memorize the formula. Okay. Now, with that being said, that sort of style of thinking only applies to specific shapes. So if we move on to example number 2 over here, and we decide to now work with circles, we run into a little bit of a different uh, sort of situation, right? In this case, when we work with circles, whenever we work with circles, we know that we are working with pi and a radius and a circumference. These are the three factors or elements that we always use when it comes to circles. So if I'm looking at a circle over here, I draw a radius and I tell you that the radius is equal to 20 millimeters. How do we go about calculating the perimeter of this kind of shape, grade eights? Remember, it's not going to be so easy to get the perimeter this time round. I cannot just take a ruler and try and measure the length of this line, right? Maybe if I had a piece of string, I could do that, but that's not quite going to work in grade 8. So instead, we now run into a situation where we have no choice but to calculate the perimeter of a circle using the formula that we need to memorize. So the perimeter of a full circle is equal to 2 pi r, right? So if we go and substitute in this case, we know that pi will remain exactly as is, and our radius has a value of 20. And I'm just going to move this over here for the sake of this example. So the perimeter is 2 pi 20, which is the same as 40 pi, but you can put this straight into your calculator. And when it comes to the world of measurement grade 8s, we always round off to 2 decimal places unless we are told otherwise. So if we convert if we convert 40 pi into a decimal, we get 125,66 millimeters. Not millimeters squared, not millimeters cubed, just plain old millimeters. So in this case, the point of this example is to remind you that there are certain formulas that you do have to memorize. You don't have a choice when it comes to that. So as far as circles are concerned, grade 8s, please remember the following. And you must memorize this in preparation for tests or exams. You can be asked about the perimeter of a full circle, of a half circle or a semicircle and of a quarter circle. So, what are the formulas for calculating the perimeter of these different pieces of a circle? We know that a full circle is 2 pi r. We've just gone and used that now. For a half circle, it is pi r plus 2r. And finally, for a quarter circle, it is a half pi r plus 2r as well. So when you're working with circles, please make sure that you know these formulas. Now, it is to some degree quite easy to remember. Let's say, for example, I have a quarter circle over here. It's not perfect. If I know that this arc that we see is a quarter of a circle, if a full circle is 2 pi r, and now I just want a quarter of that, I'm looking for a quarter times 2 pi r. That is where the half pi r comes from in this formula over here. But where does the 2r come from? It comes from the radii that help to subtend that arc. So over here, I have a radius, and over here, I have another radius, right? First and second radius, which is why we go ahead and say that the perimeter of a quarter circle is half pi r plus 2r. So again, guys, I've given you the formula for each of these fractions of a circle. And if you want to memorize them, that works. But if you prefer to study it in depth and understand where these formulae come from, you can also do that, right? And you can figure out what the uh, formula for the perimeter of a quarter circle is, as long as you know the fundamental formula for a full circle. Okay. So it's up to you guys as to where you get your formulae from, whether it's from your own derivations or from um, just recalling formulae that you've memorized. It's completely up to you. Okay. So quickly make sure that you copy this information down. If you guys have any questions, please make sure that you ask me now. Okay. Somebody has also mentioned wanting to go through simplifying fractions, and I will also try and give you dates for that because I believe we have also covered fractions already, but I will give that to you at the end of today's lesson. All right. Do we have any questions so far, grades 8s, or are we all on the same page, guys? It's very important to keep in mind that everyone thinks perimeter and area is so easy. And it is actually easy, grade 8, as long as you understand the fundamentals. Okay. And you know your formulae. This is very much a plug and play topic, meaning that if you have the formula, as long as you understand how to substitute the correct values, you will be fine. Okay. Now, circles is pretty much the trickiest shape to work with when it comes to understanding perimeter. If you think of any other shapes, it's usually a quadrilateral of sorts, right? Whether we are talking about triangles or parallelograms, it doesn't matter because it's quite easy for us to find the perimeter of these shapes as long as we know the length of the different sides or we're able to find them. Okay, so we don't really need a formula for the perimeter of a triangle. If you really wanted to write it down, the perimeter of a triangle is side 1 plus side 2 plus side 3, which is not necessarily all that helpful to memorize, right? As long as I know that perimeter is the length of the outline of a shape, I can look at a triangle and just add up the three lines. I don't need to memorize this formula to get that right. The same thing is true for that of a shape like a parallelogram. Okay. When I look at shapes like a parallelogram, again, I am adding up the sides. I know that when I look at a parallelogram, these sides are equal in length and these opposite sides are equal in length, right? And we talk about the length and the width as well. So the um, perimeter of a parallelogram is the same as a rectangle. 2 times the length plus 2 times the width, right? So I could spend half an hour writing down a list of these different formulas that we need to remember for the perimeter of every shape. But in reality, the only ones that we need to really understand is a square, a rectangle, a triangle, and a circle. Most of the other shapes that we find ourselves working with, we can calculate using our understanding of the basic definition of perimeter and these four shapes. Okay, now you might say, okay, sir, but then what about something like a kite, right? In a kite, we know that there are two sets of equally lengthed sides. So I would add up side 1, 2, 3, and 4. And that's the perimeter of your kite. So your understanding of area and perimeter, surface area and volume is going to be complemented by your understanding of the properties of these different shapes. Okay. I hope that that makes sense, guys. So that's really all we're going to talk about today as far as perimeter is concerned. And I hope that that makes sense to everyone. I haven't seen any questions just yet, so I'm going to assume that you guys are okay for me to move on. Those are the fundamentals of perimeter. Keeping this information that we wrote down at the beginning of the lesson in mind. But that brings us to our next topic, which is where things get a little bit more interesting, the world of area. So, area is the amount of space taken up by a 2D shape, and it's measured in squared units, grade 8. So, we're talking about millimeters squared, centimeters squared, and so on and so forth. So let's go ahead and take a look at some examples of this. We can quickly write down a new little subheading, just saying examples again, where the question will read, calculate the area of the following. Okay, calculate the area of the following. Example number 1. Actually, before I dive into examples, let's just write down some important um, formulae that we need to know. When it comes to area grade 8s, the same rule applies. We need to understand the basic formulae for this section of work. And then when we look at some really complicated shapes, you'll see that it's actually just a combination of simpler formulae. So, first, the area of a square is just any side squared multiplied by itself. The area of a rectangle is the length of that rectangle multiplied by the width. Right? These are basic formulae, grade 8s. The area of a triangle, you guys should also know, it is half times the base times the perpendicular height. Remember, if I say base times height, this dot means exactly the same thing as a multiplication symbol. Okay. So these are the first three most important formulae. And then, of course, just like I said to you in the last section of work, in the perimeter section, if we can understand the area of a square, a rectangle, a triangle, and a circle, we can generally find the area of most complicated shapes. So we've got the area of a square, a rectangle, and a triangle, but let's quickly talk about the area of a circle. The area of a full circle is equal to pi r squared. So if we want to use this information and work backwards a little bit, if I know that a full circle is pi r squared, what happens if my teacher only wants half of a circle, right? Of a semicircle? Well, it would just be half the area of a full circle. So a half times pi r squared. The same thing is true if I wanted a quarter of a circle. I just need a quarter of a full circle, right? So I would say a quarter times pi r squared. And just like that, you guys now have the area formulae for the most commonly tested fractions of a circle. And guys, with an understanding of these basic area formulae for these basic shapes, we can really begin to find the area of all of the more complicated shapes. Now, this is a section that some students get really nervous about when in reality it's not necessary. I'm going to show you guys one or two examples again. And guys, we've only got 15 minutes left of today's lesson, so I'll give you an opportunity to copy quickly. But given that you guys are grade 8 now, I need you to please keep in mind that I could teach this section of measurement for 5 hours if I had the time. But I'm trying to give you guys all of the information that you need to go and try questions on your own. So you need to please understand that in order for this lesson to be useful, it's going to require some practice. Okay, so let's take a look at those examples that I mentioned. Example number 1. A parallelogram. You are asked to find the area of this parallelogram over here. Now, I want you guys to please just hear me when I say this because it's actually a very helpful way to think about this section. Whenever I look at a complicated shape, right? It can be this or something that looks a little bit more confusing. We generally refer to these as compound shapes. Now, the reason why I'm telling you this is because compound shapes, 95% of the time, can be broken down into smaller, simple shapes that we've already discussed over here in the section above. So, looking at a parallelogram, by drawing two vertical lines, guys, we find that we actually have two triangles that are equal in size because of the properties of a parallelogram. And we also just have a large rectangle over here on the inside, in the middle between the two triangles. So looking at this shape over here, if we were asked for its area, let's quickly give it some values, some dimensions. Right, there we have it. Um, that is all the information that you are going to be given in a question like this. So if I was asked to find the area of a shape like this, we always start by stating that area has the symbol A. Now, if I look at this shape that I want to find the area of, it's going to be made up of a few pieces. So my best bet is to start a question like this with a game plan. I could say that the total area of the shape is equal to the area of a triangle plus the area of my second triangle plus the area of my rectangle. Now, you don't have to use little shapes like me. You can label this shape 1, shape 2, and shape 3 if you really wanted to, and say A1 plus A2 plus A3 if you wanted to. The naming conventions are up to you if there's nothing specific given in your test paper. So if I want to find this total area, the area of a triangle is always going to be half times base times perpendicular height. But it appears that I have two of these triangles. So I can repeat this or just multiply the previous bracket by 2. That's up to you guys. Triangle plus triangle, and the area of a rectangle is length times width. So the area for the shape has already been determined. All it is two triangles and a rectangle. And you guys have calculated the area for more than enough of these shapes to know how to do this. So let's go and fill in our information. Looking at our first triangle, let's say it was this triangle on, oh, sorry, guys. It was this triangle on the left over here. We know because of the properties of a parallelogram that this is also going to be 2, this will be 8, and this will be 6, while this line on the inside is 5. So what is the base of this triangle over here? Looking at this triangle, the base is going to be either the number 2 or the number 5. It depends on which way you choose to view it. Let's say that the base is the number 2 over here. We're going to have a half times the number 2. And what is our perpendicular height? Remember, perpendicular means it forms a 90 degrees with the base. So it's this line on the inside, the number 5, not the 6. So we will put the number 5 in there and then repeat this calculation because our second triangle is identical. And finally, the area of a rectangle, length times width. Looking at the orange rectangle in the center, we have a length of 8 centimeters and a width of 5. So if we go and put all of this into our calculator, we get 5 centimeters squared plus 5 centimeters squared plus 40 centimeters squared. How do I know that I'm working in centimeters? Because of the information given in the diagram. So when I add all of this together now, 5 plus 5 plus 40 gives me a very perfect total of 50 centimeters squared. And there we go, grade 8s. You now know how to calculate the area of a parallelogram. And we didn't even use a formula. All right. I hope what I've done in this calculation makes sense to you all. Oh, yeah. Right. So, guys, just to prove my point one last time, and then we are pretty much out of time for today. The alternative to this would be to use the area formula for a parallelogram, which you might not have learnt, and that's okay. The area of a parallelogram is the base of that parallelogram times the height of that parallelogram. And we would talk about the perpendicular height, right? So just very quickly, the base of my parallelogram, would be this full length of the line at the bottom. 8 plus 2 would give me 10, right? The top and bottom lines of this parallelogram are 10 centimeters long. So I could put 10 centimeters into the base's place times the height of my parallelogram. The perpendicular height, not the slanted height, is 5, like we can see on the dotted lines in the diagram. And if we go down this route, yes, it is quicker. It most definitely is. 10 times 5 gives us 50, and centimeter times centimeter gives us centimeters squared. And so, guys, to prove my point, if you want to memorize the formula for a parallelogram, you are more than welcome to. But you can see that we are able to arrive at the same answer regardless of the method that we choose to use. Okay, I'm going to move this just to the side here. So there are your options, grade 8s. I hope it all makes sense. So the function of today's lesson, guys, was for me to show you that it's really important for you guys to choose how you want to approach this topic, right? Certain teachers will tell you you have to know the formula. Other teachers will let you figure it out on your own. And so it's really, really helpful for you guys to sit with yourselves and say to yourself, okay, which way am I going to choose to do this? Do I want to learn the formula? Do I want to learn how to figure out the formula as I go using the simple shapes that we've discussed at the top over here, which make up most of the shapes we look at? Or do I want to learn both ways of doing this? Of course, guys, I would suggest you try and learn both ways, but you need to think to yourself, am I the kind of student that's very good at memorizing stuff? If so, go ahead and memorize the formulae. Okay. But keep in mind that you are then going to have a lot of formulas to learn. The other alternative is that you teach yourself the basics really, really, really well, and you slowly practice how to find the area of these compound shapes by using or by breaking these compound shapes down into the smaller, more manageable pieces. Okay. So, guys, I really wish I could sit and go through more examples of this with you guys. And if you want to spend some more time going through this section of work, I have three suggestions for you. Number one, if you want us together as a group to go through some more of this again next week, please type a comment into the comment box saying, "Sir, please can we do a part 2 of this lesson?" Then I will bring some more complicated examples, maybe some from tests and exams that we can look at and go through slowly, piece by piece. If I don't see anybody asking for that, I'm just going to move on to surface area in our next lesson. Okay. Remember, these lessons are more for helping you understand the small things that you maybe missed in class. It is not necessarily for me to teach you everything from scratch. My second recommendation would be to practice. Guys, take the information we've discussed in today's lesson and practice as much as possible. And number three, go ahead and um, use the recordings of these videos to practice if you get a little bit lost while you are doing some examples on your own. Now, unfortunately, guys, my iRainbow is just giving me a little bit of trouble today because I've got so many things happening on my laptop. So I want you guys to please go onto iRainbow on your own. You are going to click on grade 8, right, for your section of work. Then you are going to click on the topic of measurement. And once you've done that, you can then click on the section called area and perimeter. And I would suggest you write this down. Area and perimeter of 2D shapes. All right. So this is where you can find some really cool quizzes that will help you to practice this section of work. But more importantly, it's also going to give you some PDFs. Okay. And the PDFs are going to explain things in a little bit more detail and maybe even give you some extra information that you find useful. Okay. So I really suggest that you guys go ahead and take a look at this section of work on iRainbow. I think that it would be really beneficial for you guys. I would not be suggesting it if I thought it was going to be a waste of your time, because I know that you guys of grade 8, as grade 8, sorry, have got more than enough to deal with on your plates. All right. But guys, that's going to be it for today's lesson. I'm sorry it's ending so soon and that we don't have time for more, but we are going to have to meet up again next week for some more work. This is paper 2 work, and I know that it will be in your exams. So I hope that this is helping you guys with some kind of revision. Maybe it's a form of studying. But if you have any questions, you've got 2 minutes, guys. Please quickly ask any questions you have in the comment box now. All right. Grade sevens, it doesn't look like there are any other questions, guys. So I'm going to assume that everyone is happy for today. Please remember that this topic of measurement also involves surface area and volume as well. Okay, which is what we are going to be dealing with in next week's lesson. So I hope that you guys will come and join. If you go through some practice work on um, area and perimeter and you find that you have a few problems, please bring them to next week's lesson and I will try and answer them when I get a chance. All right. With that being said, our next lesson will be next week, Wednesday, from quarter to 4 to quarter to 5 in the afternoon, like it was today. Grade 8s, good luck with the rest of your exams, guys, and I will see you all again next week. All right. Thank you so much, everyone. Enjoy the rest of your evenings, guys.